Before discussing the topic of these LAN switches and all, let me finish the presentation first. In our last class, we already discussed about this MAC address table and data frame generated by the PC and forwarded by the switch. And also this what is the working of switch and in which layer is working this switch also we already discussed. Switch build their own MAC address table by examining the source MAC address of incoming Ethernet frame data. It's analyze the incoming information. When a frame is received on a switch port and the source MAC address is known, the switch create a new entry in the MAC table. This is the logic system of the switch. Okay. Here also it's clearly highlight this graphics highlight that how MAC table maintain the port number, the interface number with the corresponding this MAC address of all this system. Okay, MAC address of all this system. If it's detect the address, MAC address from the incoming port, then it's assign and analyze it again where it's going port, then it's compare with the MAC address tables and it switches over to this particular port. If there is no, then broadcast. So last class we also discussed this, what is broadcast domain and what is coalition domain, what is broadcast and what is coalition, and also that what is multicasting and what is unicast and what is broadcast. Switch use multicasting, we already explained what is multicasting. The multicasting is hybrid, the combination of unicast and broadcast is called multicasting, we already explained. Let's see here what is the coalition domain and broadcast domain in the LAN switching. The most common network device are router and switch in networking. Bridge and hub are absolute device. All these things are combined together to active these two devices, routers and switches. But we still hear people talking about the hubs and repeater and the bridge. Do you ever wonder why these former devices are preferred over the later one? One reason could be because they have more efficient and powerful. But what actually in the reason behind their efficiency? This is where terms like coalition domain and broadcast domains comes into the picture. So it's come out due to this point, coalition domain and broadcast domain. What is the coalition? Coalition domain is a scenario in which when a device sends out a message to the network, all other devices which are included in it, coalition domain, have to pay attention to it, no matter if it was destined for them or not. This causes a problem because in a situation where two devices send out messages simultaneously, if they send out information at a same time, in the same time, okay, in the same time, then it will collide. It's create a collision. So a collision will occurs, leading them to wait and retransmit their respective message on one at a time. Remember, it happens only in case of half duplex. Half is a half duplex means we cannot transmit data at the same time using hub. That's why it's very slow. To manage those collision domains, we have a CDMS slash CD. Carrier sends multiple access collision domain. So in the carrier sense, all the devices sense the device, okay, monitor the device, whether is it a busy device or not. Whether it is busy, then it doesn't send the information. Then if it is not busy, then it send the informations. This is called the CSMS slash CD mechanism in the collision domain. And let's move on to the broadcast domain. Broadcast domain is a scenario in which when a device sends out a broadcast message, all the devices present in its broadcast domain have to pay attention to it. This creates a lot of congestions in the network. This is very, very clear in this broadcast domain. Switch is working like a multicast. Sometimes it broadcasts, sometimes it unicasts. Switch also comes under the broadcast domain because it broadcasts the signal. Hub is completely, fully a broadcast domain. It broadcasts and also it is a collision domain. There is no mechanism to send simultaneous signal. This is the of the blacks. Okay. These create a lot of conditions signal that were commonly called LAN congestions, which affect the bandwidth of the users present in the network. For this, we can realize that more than a number of collision domain and more a number of broadcast domains, the more efficient in the network provide better bandwidth to all its users. Okay, let's see here impact of the collision and broadcast domain on LAN design. Hub is a broadcast domain as well as the collision domain. Switch is the broadcast domain. Okay, but there is no collision domain. Switch is the multiplex. Okay, routers. Let's see. Routers not only breaks collision domain but also break the broadcast domains. Means it is both collision always broadcast domain separators. A router create a connection between two networks. A broadcast message from one network will never reach the other once, as the router will never let it pass. So these are the advantages of the routers. We'll learn it later. So what is the routers and how it's work and what are the protocol maintained by the routers and how it's maintained the topologies and how we share their routing information. All this we'll learn it later. So routers breaks question domain, but also break the broadcast domain. Okay, that's all for the historical precisions of this LAN switch and summaries and working of the switches. And move on to this virtual LAN. How we are going to manage a virtual network inside the LAN. Physically, we are interconnected with the device, host computer. Host computer physically is interconnected, but logically is separated the network inside the physical network. This is called virtual area network, or we can say a VLAN, are a group of logical computer that appear to be on a same LAN, irrespective of the configuration of the underlying physical network. Network administrators who admin the network system partition the network to match the functional requirement of VLAN, so that each VLAN comprises of a subnet of port on a single or multiple switches or bridges. These allow computers and devices in a LAN to communicate in a simulated environment as if it is a separate LAN. So, virtual LAN is the logical LAN inside the physical network in an organization or in a department or in a company. So this will administered by the network administrator based on the requirement and and function of the different department. Let's say in the company or in the corporations, there are different types of groups for functionality. Let's say financial, sales, account, store. There are different types of groups out there. All these grouped groups functionality, we can logically divide it using the switches. Let's say suppose all the computer located inside the company or maybe a corporate, those machines are physically connected to a switch device physically, but inside the admin sections, they have to transfer the data, then they have to print in the network printer, and also they need to share their files inside the cells. Okay, inside the sales sections, but all those networks are interconnected in a single switch. That's why it's create the collision domain here. Sorry, broadcast domain here. It broadcasts to all the ports. It broadcasts to all the physical ports. That's why it broadcasts to all the physical port, That's why it's create a problem in the network. Now it's come up this virtual land. It's come into a picture due to this problem. Maybe in the finance section, also in a company, all those computers are connected in a single line. But all these incomings are needed to forward it if it is the initial stage or one computers are connected freely, then it broadcasts it to the network. It broadcasts to the network. So all these connections are interconnected with each other. So it's broadcast to all the port. If we create this virtual land using this VLAN technology, VLAN virtual logical LAN for the sales, logical LAN for the accounts, logical LAN for the stores, logical LAN for the finance, logical LAN for the establishments. Then, if it is sent from this a single virtual LAN within the single virtual LAN, then it broadcasts only in a particular virtual LAN only. It does not goes out to the outside network. This create the advantages of uh, 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 broadcast. Okay, traded in the broadcast. It does not broadcast to all the network. It's only sent in this virtual LAN area only. But if it is needed to go up outside the network, then it's forwarded to the outside. Then the virtual LAN switch redirect to the corresponding virtual LAN. Say suppose if within the sales sections needed to send some data to the account sections, then it's needed to go out to the switch from the virtual LAN, then it goes out to the switch, and the switch redirect to this corresponding. Sometimes it's need the router also to make this virtual LAN mechanism. Okay, let's move on to the next point. Features of virtual LAN. A virtual LANs form sub-networking group together, device on a separate physical LAN. VLAN help the network managers to manage LANs logically in different broadcast domain. VLANs functions at layer 2 data link layer of the OSI reference model in the layer 2. There may be one or more network bridge or switches to form multiple independent VLAN. Using VLAN, network administrator can easily partition a single switch network into multiple network depending upon the functional and the security requirement of their system. VLAN eliminates the requirement to run new cable or reconfiguring physical connection in the present network infrastructure. VLAN help large organizations to repartition device aiming improve traffic management. So this also very important that large company or large organizations is aiming to improve this network traffic management for controlling the collision and for managing this broadcast. VLAN also provide better security management, allowing partitions of device according to their security criteria, and also they ensure a higher degree of control connected devices. VLANs are more flexible than physical LANs since they are formed by logical connections. This aid is quicker and cheaper configurations of device when the logical partitions need to be changed. Okay, these are the features performed under the VLAN. And types of VLAN. There are three types of virtual LAN. Protocol VLANs and port VLAN and dynamic VLANs. Protocol-based VLANs is this virtual LANs maintained by the protocols. Which protocol is going to use by this traffics and all VLAN traffics and all. A switch or a bridge segregate forward and this cut frame. The same the frames that comes to it. Sorry. That's a wording we have to change that comes to it based upon this traffic protocol. So it segregate the connections forward or discard the packet within the land or virtual land or maybe the outside of the network. This will be based on the protocol in the traffic. Okay, based on the traffic protocol. And number two is the port-based VLANs. This also called the static VLAN. This create based on the port. Okay, say suppose we are having the 24 port. If it is 24 port, uh, five ports is used for physically connected to the port 1 to port 5 is connected to the cells, or we can configure this port number 6 to port number 10 needed to physically connected to this. Okay, and port number 11 to 15 connected to another port, and 16 to 20 connected to this another groups. All these are separately configured inside the virtual LAN. This is port-based virtual LAN. Okay, 1 to 5, 6 to 10, also based on this. Okay, and dynamic LAN. Here, the network administrator simply define network membership according to device characteristics. Okay, this will maintained by the network administrator where it's required this virtual LANs, and based on this membership accordingly, then is create the virtual LANs respectively. So these are the types of virtual LAN: protocol LAN, port-based virtual LAN, and dynamic virtual LAN. Okay, now we complete the switching topics. Let's have discussions. Let's have discussions. If you have any query, then we'll discuss it. Just ask the questions in this unit and also from the previous. Any question?